Number 63, non-nuclear submarines use batteries for power when submerged. Letter A, find the magnetic field 50 centimeters from a straight wire carrying 1200 amps from the batteries to the drive mechanism of a submarine. All right, so here, right, you just got a simple current, right? They tell you that the current here is equal to 1200 amps. You are then tasked to find the magnetic field, let's say at this point. Now, first of all, if the current is traveling to the right, you can use right-hand rule number 2. I'm just making it up that it's traveling to the right. We have no idea. But if it is traveling to the right and you use right-hand rule number 2, as you rotate then your fingers around this particular loop, I don't think I probably should have showed it coming this way, like coming out of the page, then we would have realized that this would be going into the page, the magnetic field all down here. So basically, I know that this magnetic field at this point is pointing now into the page, and I realize that they're asking me a question about what is the magnetic field strength here. That is going to be 50 centimeters, or aka 0.5 meters, from the current. We have a formula that deals with that, right? The formula is simply this. The formula is going to be that the magnetic field at a certain distance to a current carrying wire will be equal to the permeability of free space multiplied by the current traveling that wire divided by 2 pi multiplied then by the distance between the current and that particular point of interest that you're trying to calculate the magnetic field strength at. So here we just simply plug it in. So this is 4 pi times 10 to the minus 7th. The current here they told us was 1200 amps. 2 pi times then that distance of 0.5, and look, right? Not bad. So it's just simply going to be 4 pi, 4 pi, whoop, third time's the charm. 4 pi times 10 to the minus 7th. All right, multiplied by 1200, then divided by parenthesis 2 pi times 0.5. And again, it comes out to about 4.8, right? 4.8 times 10 to the minus 4th, and that's Tesla. Okay, probably should have 3 sig figs, 2 sig figs, whatevs. So there's the magnetic field, okay, at this exact location. So now it says, what is the field if the wires to and from the drive mechanism are side by side? So, you know, I think what they're what are they even trying to say? I don't know. I think they're trying to say, like, what happens if these two wires are side by side, I guess, traveling the same direction? I don't exactly know. But I'll just make that assumption. So if the current here is traveling to the right, then we're going to apply right-hand rule number 2 again, right? And what we'll realize is that basically side by side, maybe on top of one another. I really have no clue. Or maybe side by side, one's traveling the other way. Do you have any idea what they're talking about? Actually, yeah, I don't really know. Maybe they meant on top of one another. I'm not really sure. So let's say on top of one another. Okay, one's traveling though the other direction because I guess that has to form a circuit somehow. So if it's traveling in, then it's got to be traveling out. I don't know. But let's just make that assumption. And we already talked about that. I'll put this now current here in red. So we already talked about that going into the page on the bottom, coming out of the page on the top. Now, if this current is then flipped, you're going to have the opposite. Coming out of the page on the bottom and then going into the page on the top if you applied right-hand rule number 2. Now, what that means is that if these magnetic fields oppose one another directionally, they should just totally cancel. All right, so I guess if they're to and from, they should just totally cancel for letter B. Cancel, meaning they'd be net a 0. Discuss the effects this could have for the compass on the submarine that is not shielded. I don't know. So if it's not shielded like it is here, this is basically shielded. The magnetic fields cancel, and then the compass can read the proper magnetic north. All right, and they can navigate. But if this isn't shielded, so they're pointing not the opposite direction, they're pointing the same direction, that's going to mess up the compass. And I think we know what can happen from there. Guys, thanks very much for tuning in. I appreciate it. Please remember to help us out and subscribe, and I will see you soon. All right, take care.